Well, welcome back to another Algebra 2 video, and tonight we've got a really wild night planned. We're really going to study graphs and all the characteristics that make them so special. One of the highlights is, as the title says, we're going to talk about finding relative maximums and relative minimums, but that's just kind of the tip of the iceberg. Before we dive in totally, the career I wanted to focus on tonight was a career in computer science. It's certainly a hot field these days, and there is again a lot of money seems to be associated with these jobs. And I like this second sentence here. It says mathematicians with their training in logical and precise thinking are highly prized in the field. And over here's a list of a whole bunch of different types of computer sciences, and a couple that caught my eye. Coding is a real big one, algorithms and data structures, programming language theory, on down the list here, a couple others, let's see. Artificial intelligence, that's a big one, of course, all the way down here to the bottom where it talks about software engineering down here. A lot of hot fields in computer science. So a real quick review, I think we feel really good about x-intercepts, and that's simply where the graph of f of x crosses the x-axis, or sometimes it'll touch the x-axis and turn back around, but we'll talk about that later. And then simply a y-intercept is again where the graph crosses the y-axis. And in this case, it certainly will cross over. Now, a graph can have at most one y-intercept. At most one. Whereas when we talk about x-intercepts, you can have multiple x-intercepts. You can have anywhere from 0 to infinity. So again, with respect to our graph, here's a 1x, 1y. The second graph here has two x-intercepts, but again, only one y-intercept at most. And our third graph has 1, 2, 3 x-intercepts, but at most just one y. We brought in a couple of cool pictures here to help illustrate our next topic. And we want to talk about when is a function increasing or decreasing. And the number one thing we want to emphasize here is it's very important that we read our graphs from left to right, the same way that we read a book. Okay, so we start at the far left side of the graph, and let's see, I'm saying starting right here, as I move from left to right, the y values are getting bigger and bigger, therefore the graph is increasing right up until x equals 2, and then I'm going to continue to move left to right, but while I move left to right, the y values are getting smaller and smaller, therefore the graph's decreasing. Now it is possible for a graph to be constant as well, so you'll notice we're increasing up until x equals -2, and then from -2 to +1 it's flat or constant. From x equals 1 to x equals 3 we're increasing, and then from x equals 3 until x equals 5 we're decreasing. Okay, what is a relative maximum? Well, it's a very specific point where the graph changes from increasing to decreasing. Changes from increasing to decreasing. And again, this picture is worth drawing in our notebook, I think, and feel free to add some little color and spice to it. But you'll notice this graph is increasing right up until bang, right there at this point, and we call that our relative max because that's the single instantaneous moment where the graph transitions from increasing to decreasing. Decrease, 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 increase, increase, and then right bang, right here, we make another switch from increasing to decreasing. So this picture has two relative maximums, and I think it's, let's put a little asterisk here in our notebook. A relative max cannot occur, and I'll abbreviate here, cannot occur at an endpoint. At an endpoint. And what I mean by that, an endpoint would be the far left or the far right edge. So sometimes they're going to change these arrows to dots and give the graph a finite domain instead of an infinite domain. And even like in this case, this might be the tallest point, and we have another name for that later in the video, and we'll come back to that. Real quick before we abandon this idea, let's say we've got this new graph has a relative max right here at approximately x equals -2.2-ish, and then there's a second one right here at x equals 2, and those are my two relative maximums. Well, if you felt good about a relative max, then I think this one's going to be crystal clear as well. A relative min is a point where the graph changes from decreasing to increasing, just the opposite. So wherever that transition takes place, that is the location of our relative minimums. And this graph again is worth copying down, and we'll see the transition take place Starting right here, the graph's decreasing, 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 bang! Right there's your relative min. And then you can see how it transitions and starts to increase. And then I'll leapfrog over here. Decrease, 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 bang! There's your relative min, right at x equals 4, and then it starts to increase thereafter. If we took a look at our second picture, and we just practiced a little bit more, where are the relative mins on this picture? I'm going to say right there is right at about x equals 0 is my first relative min, and then right at about x equals 3.5 is my second relative min. And a graph can have anywhere from 0 relative mins to, many, many multiple relative mins. Okay, now a relative min is slightly different than an absolute max. An absolute maximum value, and I'm going to highlight this right here. The word value implies y coordinate, okay? The absolute maximum value of a graph is the height of the curve's tallest point, okay? Height, again, that refers to y coordinate of the curve's tallest point. So we're kind of like crowning a grand champion of all the tall points. Who's the tallest of all of them? It is possible to have multiple points, quote unquote, tie for the tallest. But let's say you had 3 different points and they all had this they all tied for the tallest. There would technically only be one answer, because what we're doing is we're describing the height of all those points, and so we're just again focusing on the y coordinate or the height. Now in this particular picture, even though I've got a relative max here and a relative max here, the absolute max is going to be at the end point in this case. So which is kind of what we were foreshadowing in a couple slides earlier, where we said a relative max can't occur at an endpoint, whereas an absolute max can occur. And I would say this right here is the single tallest point, and so we'll label that. That's my absolute max. Now, it won't always occur at an endpoint, but it certainly can. In a nutshell, here's how I would like to summarize absolute max. It's basically what we're going to do is we're going to compare all your relative maxes to your endpoints and pick the tallest one. Okay, it's as simple as that. Take all of your relative maxes, compare them to your 2 endpoints, being your left endpoint and your right endpoint, and then pick the tallest one. Now here, the second picture that I drew is very, very similar to the first one. I just cut it off prematurely here. And so again, I've got a relative max here, and if I compared those to the 2 endpoints, of those 4 points that I just circled, who's the tallest, or who's the grand champion? And I would say winner, winner, chicken dinner right here. That point right there is your absolute max. And whatever, on the test, there would be a y-coordinate corresponding to that height. Alright, an absolute min, again, if absolute max made sense, then this is going to be pretty crystal clear here. It's the value of the graph is the height of the curve's lowest point. Height of the curve's lowest point. So we just got to find the lowest point on the graph. It's possible to have multiple points tie for the shortest point or the lowest point, but again, we're focused on the height, so just pick the height. On this particular picture, I've got a left endpoint here, I've got a relative min there, I've got a relative min here, and here's my right endpoint. So of those 4 points we just circled, who's the lowest of all of them? And I would say winner, winner, chicken dinner. This point right here, it's not only a relative min, but it's also an absolute min. So it is possible for a point to be both a relative and an absolute min. Let's take a look at a second picture where maybe one of the endpoints happens to be the absolute min. Alright, I'll draw my axes real quick here. Bada bing, bada boom. And let's see. I got a little graph doing a little dance like this. And in this case, I've got my left endpoint. I've got a relative min right here. And then I've got my right endpoint. And so I'm comparing all of my relative mins, which there was 1, to my 2 endpoints. And the lowest of all of them is right here. Winner, winner, chicken dinner, absolute min. So it's possible for an absolute min to occur either at an endpoint or at an interior point. This next one is maybe the most confusing as far as our notation goes, but I think graphically it might be one of the simpler ones. So my question to you today is, what does it mean to say that f of x is greater than 0? What What does it mean to say f of x is greater than 0? How do we interpret that and kind of translate that to English, so to speak? Well, remember, f of x and y are interchangeable, okay? So every time I say f of x or every time I print f of x, you're more than welcome to replace it with a y. So let's rewrite this statement and say that y is greater than 0. What we're really trying to say is that y is positive, okay? Now graphically, what we're really focusing on is the parts of the graph that are above the x-axis, and that's all you need to know. We're going to find what parts of the graph are above the x-axis, aka what y values are positive. So what I'm thinking is starting right here up until right around there is where the graph's above the x-axis, and then again starting at 4 all the way to infinity. So if I was describing these two intervals using interval notation, I would say from -3 to -1 and from +4 to positive infinity. Those are the two intervals for which f of x is greater than 0. Now another way to write those two intervals is we could say something like -3 is less than x, which is less than -1, union 4 is less than x, which is less than infinity. And of course the union symbol just means we're joining those two sets together. Conversely, what does it mean to say that f of x is less than 0? Any guesses? Certainly I think you feel this one coming. If we replaced f of x with a y and we said y is less than 0, what we're really focusing on is what y values are negative. Okay, that's what it means to be less than 0. Graphically, we're focusing on the parts of the graph that are below the x-axis. So let's see if we can identify them on this wonderful picture. I would say from -infinity to -3, and then from -1 until -2. Now remember, right at +2, something really special is happening. We're saying like right at x equals 2, the graph's neither above nor below. So I'm not going to include x equals 2 in my set or my answer. And then I would say from +2 until +4. So I'm looking at 3 intervals right here that I'm going to say. So I said from -infinity to -3. That was the first interval right here. Then I'm going from -1 to +2. And then I'm going from +2 to +4. And because I'm using parentheses here instead of the square brackets, what I'm doing is I'm excluding 2, or I'm not including 2 into my solution set. Alright, we're going to try to put it all together. I just drew a little graph on some graph paper I had here at home and took a picture of it. And we're going to buzz through all the topics we hit tonight and see if we can put it all together and just practice it a little bit more. And first things first, what are the x-intercepts? And again, we could have as many as 0, or I should say as little as 0 or as many as an infinite, I guess technically, number of x-intercepts. I've got one right here at x equals -7. I've got one at x equals 3 and one at x equals +7. So, and again, I like to, instead of just putting the numbers down, I like to say x equals -7, x equals +3, x equals +7. Now as far as the y-intercepts, now remember, you can have at most one y-intercept, and that bears right here, and we'll say y equals 7. When's f of x increasing? Now remember, we're reading from left to right, so I would say starting at, I think this is x equals -9 right here. From -9 up until x equals -5. So I'm going to go -9, comma, -5. And hopefully that looks like a 9. Then starting at -2 until x equals +1. -2, +1. And then one more time, there's an interval starting at x equals 5 until x equals, looks like 8. So we'll say from 5 to 8, f of x was increasing. Now, when is f decreasing? Well, it's all the intervals that we skipped over. So from x equals -5 until x equals -2, -5 to -2, and then again from +1 until +5, 1 to 5. And again, as long as you're reading the graph from left to right, it's almost like you could pretend you're riding a roller coaster and you just ask yourself, I'm going up, 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 down, 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 up, 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 down, 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 up, 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 and it's as simple as increasing and decreasing. Now, where is the relative max located at? Now, remember, a relative max cannot occur at an endpoint, so let's just rule out these two endpoints are not options, all right? It has to be a point where the graph changes from increasing to decreasing, which I think is right here. You can notice how we're increasing and then we're decreasing. So write at x equals 5, or negative 5 I should say, and make sure instead of just putting negative 5 on your paper, write x equals negative 5. We want to be as specific and as clear as possible. And then I think there's a second one here at x equals 1. We're increasing and then decreasing. So there's my second one. Now as far as relative mins, I'm going to say there's one right here at x equals negative 2. That's where the graph's changed from decreasing to increasing. And then there's going to be another one here at x equals 5. We changed from decreasing to increasing again, x equals 5. And that should do it. Okay, alright, we're ready for the absolute maximum value. And remember, the word value implies y coordinates. When I'm all done with this question, I'm going to say y equals blank is my absolute maximum value. Now what we're going to do is we're going to compare your two relative maximums to your two endpoints, and we're going to pick the tallest of those four. And I'm thinking winner, winner, chicken dinner. Now the answer is I'm not going to say x equals 1 because I'm focusing on the height, and I'm going to say y equals let's see, it looks like 8 is the height of that particular point. I think that's 8 right there. Now as far as my absolute minimum value, I'm going to take my two relative minimums, I'm going to compare them to my two endpoints, and I'm going to pick the lowest point of those four, and I think my grand champion's right down here at x equals negative 9, but again I'm looking at the y coordinate, which is going to be negative 5, so y equals negative 5 is the absolute minimum value. Our very last question of the night, we're going to talk about when f of x is greater than 0 versus when f of x is less than 0. And remember, when we said greater than 0, we're talking about what parts of the graph are above the x-axis. So again, let's go ahead and we'll try this one. And I'm thinking starting at negative 7 all the way up until positive 3. So we're going negative 7 comma positive 3. But that's not the only time. I almost forgot about this little rascal hiding over here, and that would be from 7 to 8. So I'm going to try to squeeze that in there, and hopefully it doesn't get too piled up. There we go. And then, let's see, when is f of x less than 0, aka below the x-axis? And we're saying from negative 9 up until negative 7, negative 9 comma negative 7, and then from positive 3 until positive 7. X equals 3, x equals 7, that's when it's below. And remember, this like negative 9 kind of represents the starting point of that interval, and negative 7 is the ending, 3 is the start, 7 is the ending point. And again, we're going to get in a lot of great practice tomorrow. First half of class, you're going to work with a partner, and the second half of class, you're going to fly solo and really get a chance to show off your skills. So have a great night, and we'll catch you tomorrow.